Hello learners. In this lecture, we will study about analysis of variance and covariance, which is also known as ANOVA and ANCOVA. I, Kriti Verma, deliver this lecture on this topic. First, we will just see the outlines that in this lecture we will study introduction, what is ANOVA, assumptions in ANOVA, classification of ANOVA, one-way ANOVA, two-way ANOVA, and some numericals. Introduction. This statistical technique, first developed by R.A. Fisher, was extensively used for agricultural experiments. Analysis of variance ANOVA is the method for testing the hypothesis that there is no difference between two or more population means. The significance of the difference of means of the two samples can be judged through either z-test or t-test. When there are more than two means, it is possible to compare means more for each pair using multiple t-tests. Conducting multiple t-tests can lead to inflation of the type 1 error rate. In such circumstances, we do not want to consider all possible combination of two population at a time. For that, we would require a great number of tests before we would be able to arrive at a decision. ANOVA can be used to test differences among several means for significance without increasing the type 1 error rate. An extremely useful technique concerning researches in the many fields of economics, biology, education, psychology, sociology, business, industry, and in researches of several other disciplines. Example: a group of psychiatric patients are trying three different therapies: counseling, medication, and biofeedback. We want to see if one therapy is better than the other. Second example is a manufacturer has two different processes to make light bulbs. They want to know if one process is better than the other. Third example is the students from different colleges take the same exam. You want to see that if one college outperforms the other. Okay, so here what we are doing that we are just judging that one therapy is better than the other, or one process is better than the other, or one college outperforms the other. So there is a comparison between two. What is ANOVA? ANOVA is a procedure for testing the differences among the different group of data for homogeneity. Okay, the essence of ANOVA is that the total amount of variation in a set of data is broken down into two types: that amount which can be attributed to chance, and that amount which can be attributed to specified causes. Thus, the basic principle of ANOVA is to test for differences among the means of the population by examining the amount of variation within each of these samples relative to the amount of variation between the samples and groups. Assumptions in ANOVA. First, the parent population from which sample groups are taken is normal. Independence of samples, that is, each sample is randomly selected and independent. Uh, Homogeneity of variances or of the group, equal variances among groups. The experimental errors of data are normally distributed with mean 0 and various sigma square. The effects are additive in nature. So classification of ANOVA. ANOVA is of classified into two ways, that is one way ANOVA and two way ANOVA. So what is one way ANOVA? When only one factor is considered, then it is called one way classification. The total variance is equal to the variance between groups and the variance within groups, or residual variance. For example, in an experiment, three groups are selected for an experimental treatment on one factor, that is evaluation of performance of the three groups on the basis of their attitude scale. So this is the example. Now this is very important part, that what is the formula for ANOVA. So this is very important part. Here you can see that what I have written: sources of variation. Sum of square can be represented as SS. Degree of freedom can be written as DF. Mean square MS. This is SS divided by degree of freedom, and is an estimation of variance to be used F ratio. So you can see that F chart, you can see to the back of any of your books, but here also I have explained. And F ratio we have to find it. We have to find two types of thing, like between sample or categories, or within sample. For between sample the formula is this, and for within sample the formula is this. To find out the degree of freedom, you have to use this formula k minus 1 and n minus k. And to find the mean square, you have to, between sample, you have to use the formula ss between by k minus 1, ss within by k n minus k. ठीक. And within sample the formula is ss within by n minus k. So the question is, yeah, or generally learners are confused in what is the meaning of n and k. So n is total number of item in the sample, that is n1 plus n2 plus nk, and k is number of samples. Okay, so and you have to find out F ratio. So F ratio is ms between by ms within. So this is the overall formula for finding out one-way ANOVA, analysis of a variance for one-way ANOVA. And there are k samples having in all n items. All n means all items is n, and samples, how many samples we have taken, that is known as k. So yeah, first I am explaining what is null hypothesis and alternate hypothesis. As you know that null hypothesis can be represented as H0, and alternative hypothesis can be represented as H1. So when the mean of all the groups are same, so it is H, not null hypothesis. And if alternative hypothesis, if mean of all of at least two are not same, so it is alternate hypothesis. So total variation partitioning means here total variation is divided into two, like variation due to a factor and variation due to chance. So procedure, what is the procedure? Now only I have explained that you have to first obtain the mean of each sample, work out the mean of the sample, calculate sum of squares of variance between the samples, that is ss between. Then we have to find ms between. Okay, I have already explained in that chart. In that chart you have seen that we have to find out mean square. We have to find out mean square, that is ms. We have to find out mean square, that is ms. We have to find out degree of freedom, df, sum of squares, ss. And these all three things we have to find for between sample and within sample. And the formula is this: n1 in bracket x bar by my x1 bar minus x1 x double bar. So what is this? I will explain this in the numerical problem which is ahead. So afterwards what you have to find out, you have to find out, obtain mean square of mean sum of squares between samples. Then you have to find out sum of square for variance within sample, that is ss within. We are, in short, it is known as ss within. Obtain the variances or mean sum of squares, that is ms within sample. Sum of squares of deviation for total variance. And finally you have to find out F ratio. So first we will do with question. With question you will understand more properly that how to find out. So this is the question. In this question, set up an analysis of variance table for the per acre production data for 3 varieties of wheat. So 3 variety of wheat is there. It means we know that K is 3 here. Okay, 3 varieties of wheat, each grown in 4 plots, and state if the variety differences are significant or not. So 3 variety of wheat are there, and all 3 varieties are grown in 4 different plots. So we have to state that the variety difference are significant or not. So k is 3 here, and n is, what is the meaning of n here? N is 6, 5, 5. These are the n. So total number of items here 12. So n is 12. Okay, so these two things you have to remember earliest. Now what we have to do, see, in this question we have to find out the mean of each sample. So mean of each sample means x1 bar, x2 bar, x3 bar. So this is for variety A, this is for variety B, and this is for variety C. Okay, so how to find out? We will just write the values from here. we will just write the values from here, like 6 7 3 8. This is the mean. This one is known as x1 bar, and if you will find out the mean of this. This one is known as x2 bar, mean of this, and this one is known as x3 bar. So remember the things what it is written, 6 7 3 8. So similarly we have find out, with the help of this we have find out x1 bar, that is 6, x2 bar, that is 5, and x3 bar, that is 4. Afterwards, after finding out mean of each of these samples, we will find out mean of the sample means whatever the sample we have got, 6 5 and 4, these means we have got x1 bar, x2 bar, and x3 bar. Now we have to find out the mean of this again, that is x1 plus x2 bar plus x3 bar. So 6 plus 5 plus 4 by 3, that is 5. Okay, so this is the x double bar. So be careful that x double bar is 5 here, and x1 bar is 6, x2 bar is 5, and x3 bar is 4, and x double bar is 5. Okay, now next is we have to find out SS between, that is sum of squares between and sum of squares within samples. So for SS between, the formula is n1 x1 bar minus x double bar. You can go to the previous slide to see the formula. So x1 bar minus x double bar whole square, n2 x2 bar minus x double bar, n3 in bracket you have to write x3 bar minus x double bar whole square. So what we have got, we know that n1, because there are 4 plots are there, so n1 is 4 only. Okay, because the number of plots are 4, so because there is a comparison between 4 different varieties of wheats, so n1 is 4 here. Okay, but if variety of n1 is 4, but if how many varieties are there, that one is known as n. So n x bar, x1 bar we have got 6, so 6 I have written, x double bar is 5. So similarly put all the datas and you will get the s between 8. Similarly we have to find sum of squares within the sample. So within the sample, summation of x1i minus x1 bar whole square plus summation of x2i minus x bar 2 whole square. This is the formula, and here I is 1 2 3 4. So what we have to do, x1 1, then x11 is what, 6 minus 6 whole square, then x12. So what is the meaning of 1 2? See, x11 x12, here it is written x12 because we have to do the sum from 1 to 4, then x13, then x14. So what are all these? Here it is 6 7 3 8. So it is nothing but 6 7 3 8. It's nothing but these formulas. Okay, these one, 6 7 3 8. Okay, so we will write all these values in place of the formula. Okay, and after substituting all values, you will get the result as 0 plus 1 plus 9 plus 4, then 0 plus 0 plus 4 4, 1 plus 0 plus 1 0, and after addition of all these you will get 24. So this is the sum of squares within. Now afterwards, finding out the sum of squares within, sum of squares for the total variance for formula is this, summation of ij xij minus x double bar whole square. So if you will substitute the values, you will get this result. This is the formula, and just substitute one by one. I11, then j11, j1, then I2, j1. Like this you have to substitute the values and you will get this result. So SS for total variance is 32. Alternatively, if SS for total variance can also be worked out, and the formula for SS for total is SS between plus SS within, and we have got SS between 8 and SS between 24. So just add this 24 and 28, you will get 32. Next is how to calculate this. We have to write source of variation between sample. We have got 8 and 24. degree of freedom, like n minus 1 by k minus 1 was the formula, so 3 minus 1, that is 2, and degree of freedom within the sample is n minus k, so 12 minus 3, that is 9. So now mean square means ss divided by df. This was the mean square, so just 8 divided by 2, we have got 4. 24 divided by 9 got 2.67. Now f ratio, to find out f ratio, what we have to do, we have to find out for f ratio, what was the formula. For to finding out f ratio, our formula is this one, like between that is ss between divided by ss within. So 4 divided by 2.67, you'll get 1.5. okay, now we have to find out the level of significance. okay, we have to find we are finding out level of significance, that is 5% f limit. So this one we can find out with the help of degree of freedom. We have to find out the value of 2 4. So here is the table. okay, here is the table, you can look from here, 2 and 4. no So 2, this one, second column is 2 and 4. okay, so we have got 4.26. 2 and 4, no, it's 2 and 9. So we have got, okay, here this one, and 9 is here, so 2 and 9, it will be 4.26. okay, 4.26 is the value. 4 point, this one, this is second table, and this one is the value for 2 and 9. So this one is 2 and 9. So you will just substitute all the values for here. f29 is 4.26. The above table shows that the calculated value of f is 1.5. okay, f ratio, when we have when we have got f ratio, that time our value is 1.5, and for 5% f limit we have got 4.26, which is less than the table value 4.26 of at 5% level, level with a degree of the freedom v1 is 2 and v2 is 9, and hence could have arisen due to chances. This analysis support the null hypothesis, means if value is more than f ratio is more than 5% f limit, then it supports the null hypothesis of no difference in is sample means. We may therefore conclude that the difference in wheat output due to varieties is insignificant and is just a matter of chance. okay, so this is all about how to find out the ANOVA in one way. In the next video we will study that how to find out ANOVA for a two way, and we'll do one question also in one example also. In that example, in that numerical method, there will be the formula for finding out analysis for variance in two way, and we will also study about analysis of covariance. So this is all about this first lecture on ANOVA.